Okay, so for question number 17, and this is in chapter 8 in the ThinkDo, they're telling us this is a t-test, but how do I know? If I didn't know that, how would I know that? If they didn't tell me this, how would I know that? So I'm reading through, and they say on average people get about 7 hours of sleep. Well, I don't, but oh well. You select fit, so I get n equals 50. I'm just picking out some information as I go along here. And from the sample, we know, so the sample mean is 6.2. That's more like what I get. Actually, it's a little bit longer than I'm getting right now. And the standard deviation, and that's from the sample, right? That's from the sample. So that's not, so that's S, that's not that little lowercase sigma. Remember, that's the population standard deviation symbol, standard deviation, and S is the sample standard deviation. And remember, mu is the population mean. Mu, we pronounce it population mean. Of course, you knew this, population mean. And X bar is a sample mean. So I don't know the population standard deviation. So that means I've got to use the t-distribution. Well, there's some things I got to check with first. I mean, make sure the central limit theorem holds, right? Let's see, distribution. So is this a random sample? Well, it tells me it's random, so that's good, right? It tells me right there that it's random. And then n's 50, and as long as n is bigger than 30, we know the distribution of these sample means will make a normal distribution, right? And if you watch that guy back when we looked at chapter 6 in sampling distributions about the piles of x bars, well, we know this pile of x bars for all those samples of size 50 will make a normal distribution. So that allows us to do that. So what's the claim here? That's always the first thing we want to do. What's the claim? Seems reasonable that we can claim that college students sleep less than average. So that's the claim, right? Let's see. I'm gonna try it this way, and we'll see where it goes. So HO is going to be the mean for your college student sleep is the same as the general population of 7 hours. And we're trying to say that the claim says that, no, they get less than 7. So this is the claim, right? So then we're going to do, what do we know? We know some situations here where we could go do the formulas like what Dr. Stevens shows us. We can also use this Rossmann-Chance applet because that does the t-distribution here. Let me minimize this a little bit so I can see my page here. Okay, so I'm going to go out of that Rossmann-Chance applet. We're going to select one mean. Now this does t-distribution, not z-distribution. So if you have data, you can paste it in and have it do that. But we don't. We have the summary. So we know n is 50. We know X bar for that 50 was 6.2, and we know the standard deviation with that 50 was 0.75. And we're going to let it calculate, so use it. And then our hypothesis was what? Our hypothesis was equal to 7 and less than 7. So it's a left-tailed test. So let's come back here to my applet. I'm going to make this be 7. But make sure you check test of significance, right? If you don't check this, right, when you first load this page, it looks like this, and we want a significance test, not a confidence interval here. I'm going to change the mean to 7, and it'll automatically kick less than 7. And something doesn't look right here. Here we go. So this tells me, so what did I get out of this? I got here, where's my pointer? I got n's 50. So I just want to make sure because I haven't done this by hand, so I want to make sure that's a reasonable answer. Yeah, I guess so. I guess remember the standard deviation. If we were going to do this by hand, right? The t-score, the test statistic for this would have been 6.2 minus 7 over this 0.75 over the square root of 50. This is going to be a pretty small number. So 0.8 divided by that pretty small number. I'm not surprised the test statistic is 7. And it is negative because we know that our sample mean was less than 7. So this is our test statistic. This is our t-score. This also tells me the probability of getting a sample of 50 college students with a mean that far away from 7, if 7 is true, is a pretty remote chance, a pretty low chance. Let me clear this out and grab this and put this on the my document here. Let me copy this. Okay. I don't need all this. In fact, why don't you know what I'm going to do? I'm going to change. Well, can I move this down and not lose everything? Do I have enough space on my, no, here, you know what we're going to do? Sorry, you watched me fumble around with this. Tell it, I'll pause it and come back. Okay, so I grabbed what I needed. So here's the here's the test statistic, -7. There's my p-value, and so that's a pretty small p-value. So I'm gonna reject HO because that's certainly less than 0.01, right? 0 or practically 0 is less than 0.01. And you kind of see why that p-value is 0, because if you think about, this is a normal curve, and this 99.7% of the distribution will be more than, of course, this is graphing. What is it graphing? Okay, yeah, that's graphing this is graphing, that's more than the point. Yeah, so this is graphing the sampling standard deviation. 6.2 is way down here, way below 1, 2, 3 standard deviations away from the mean. So we know the chance of that happening is pretty low. So I'm not surprised that's a pretty low, because remember, 3 standard deviations captures 99.7% of the distribution, and this is way outside that. So yeah, we're going to reject HO here. Let me come back and do some writing here. So we're going to reject HO. So what does that mean? Well, you can use Dr. Stevens' language. I like this flow chart. I think it's a nice visual. And you've heard me say this in other videos if you've watched those. So I rejected HO. My claim did not contain equality. See, the claim was the less than, right? Here, let me get a pointer going again so we can do that. See, the claim was H1, where it was less than. So my claim did not contain equality. And did we reject HO? Oh, we sure did. So we can say the sample data supports the claim that college students get less sleep than the average for all people. And that's how you'd word that. Don't want to say too much. You don't want to say too little. You got to say enough that, yeah, this looks like it's statistically significant. We can't say HO is false. You'll see other places in the web where they say that. You don't know that, because this could be a bad sample. So you cover your butt by not saying too much. Try to make the claim, state the claim, support the decision, but not say too much. Okay, so that's this question. This is how I would do this question out of the book with the applets.